Almost all of us have at some point in our lives gazed at the starry night sky and wondered what lies beyond. All those shining lights might be hiding worlds as complex as ours, if not more. And although our eyes are quite good at seeing distant objects, they fail to distinguish finer details at greater distances. Now, we all know that many of these tiny bright spots in the night sky are actually stars, some far more massive than even our own sun, but not all of them. Some are planets, distant galaxies, star clusters, and so on. However, due to the immense distances between us and these objects, as well as due to the limitations of our own eyes, we only perceive them as small bright dots amidst a sea of darkness. And that's not even mentioning other distant celestial bodies like moons, asteroids, exoplanets, which are virtually invisible to the naked eye. Sure, looking at the night sky, you might be able to see the moon, but its finer details are lost across the vast emptiness between us. This cloak of invisibility throughout human history led to some fascinating and often bizarre theories about the things that we could barely see, like the idea that there was a whole civilization next door on the moon, just waiting for us to get over there and say hi, or that the sun, in spite of being a giant fiery ball, actually had a cool surface with lush vegetation and was inhabited, an idea seriously proposed by the famous astronomer William Herschel in the 18th century. These theories might seem wild and irrational now, but it's not the early astronomers who were at fault. They were simply working with the best tools and knowledge they had at the time. And one of the major reasons such fantastical theories were eventually debunked brings me to the topic of this video: telescopes. The earliest known telescopes originate from 17th century Europe, and they were made famous by a rather well known gentleman named Galileo Galilei. Now, Galileo wasn't the inventor of the telescope, and he might not have even been the first to point one at the night sky. But he did improve the basic design, and more importantly, he was among the first to successfully apply it to astronomy. Like everyone else before him, Galileo began observing the night sky with his naked eyes, and mostly saw what we still see today when we look up: a vast darkness sprinkled with tiny shining lights. Some larger and more obvious bodies, like the sun and the moon, stand out, but mostly it's shining lights in a vast sea of darkness. And the reason the sky appears this way isn't just about outer space. It actually has a lot to do with the limitations of our own eyes. You see, as incredible as they are, our eyes are still quite small, so only a tiny portion of visible light from space actually enters them. The vast majority of light rays that travel all the way to Earth from distant stars and galaxies simply miss our eyes. They fall to the ground, scatter in other directions, or get absorbed. And it's from that tiny sliver of light, those few photons that do reach our eyes, that we piece together our entire view of the heavens above. And this is where telescopes make the difference. In the simplest terms, you can think of a telescope as a giant eye. And just like a bigger eye would naturally collect more light, a telescope allows us to see more by gathering far more light than our own eyes ever could. The earliest telescopes, like the one used by Galileo, worked using a pair of lenses, one convex and one concave. The front of the Galilean telescope contains the convex lens, also known as the objective lens. Its job or its objective is to collect light. As light rays from a distant object hit this lens, they are bent inward. This bending of light rays is known as refraction, and it is the reason why objects partially submerged in water appear bent. The object remains the same, it's just the light rays which get bent passing through different media. These bent light rays are then focused toward a single point called the focal point. At this point, the light forms a real image, but it's inverted, upside down. Still, this image is larger than what we'd see with our own eyes. Not because the object is truly magnified yet, but because the telescope is collecting more light, which gives us a larger view of the object. Now, to correct this upside down image, the concave lens comes into play. This lens doesn't fix the image per se, but it redirects the light rays just enough in such a way that the image appears upright to our. It also helps to spread the rays so the image appears magnified. Using this simple yet powerful combination of lenses, Galileo was able to see a magnified upright image, far clearer and larger than anything visible to the naked eye. And that's exactly what Galileo did. He worked out the math, refined the lens configuration, and pointed his telescope to the night sky, becoming the first human to witness sights no one had ever seen before. Craters on the moon, moons orbiting Jupiter, and countless stars invisible to the eye alone. Humble invention, Galileo revolutionized astronomy, and every look through his telescope brought us a step closer to understanding the universe. As amazing as Galileo's invention was, it was not without its challenges. He had to make his own lenses, as the ones available during his time were just not good enough. Grinding lenses is no easy task, and it certainly wasn't in the 17th century. And almost every major astronomer who came after Galileo worked to refine and improve the design of telescopes, like Sir Isaac Newton, who built the first reflecting telescope. Reflecting telescopes work a bit differently from refracting telescopes. Instead of using lenses to gather light, the refracting telescope that Newton used had curved mirrors instead of lenses, which solved a key problem in refracting telescopes, known as chromatic aberration, a type of color distortion caused by light bending differently through glass. Further development in the field of telescopes led to what is now known as the Leviathan of Parsonstown, a massive 72-inch 4-ton reflecting telescope built by William Parsons, the third Earl of Rosse, at in Parsonstown, Ireland. This was the biggest telescope at the time, and the record stood for more than 70 years. The Leviathan was so large that it had to be mounted between two enormous stone walls, and adjusting it required a complex pulley system. Because of its enormous size, it could only observe a narrow portion of the sky, but it did see proved to be revolutionary. Through this giant telescope, Parson observed spiral structures in nebulae, which were later revealed as entire galaxies far beyond our own. The Leviathan stood as the biggest telescope known to man, until an even bigger one, the Hooker telescope, was constructed in 1917. Further enhancements to the design of telescopes shifted the focus away from simple lenses or mirrors to collect light, and modern telescopes employ various complex techniques to provide us with a clearer view of the universe. Like the Event Horizon Telescope, for example, it's not a single telescope, but rather a global network of radio observatories working together. This international collaboration creates a virtual telescope the size of the Earth, a technique known as very long baseline interferometry. Unlike traditional telescopes, the Event Horizon Telescope doesn't rely on visible light. Instead, it detects radio waves, which are less affected by dust and interference in space, and can travel great distances with minimal interference. This Earth sized telescope was used to capture the first ever image of a black hole in 2019, a moment that made history. Although the existence of black holes had long been theorized, this image provided first visual proof. It was a powerful confirmation of decades of scientific predictions, and a testament to what's possible when technology meets cosmic ambition. Similar to the Event Horizon Telescope, one of the latest major telescopes to be released, James Webb Telescope, uses infrared light. Why infrared? Because many colder celestial bodies, like exoplanets and brown dwarfs, don't emit enough visible light to be detected. but they do shine in infrared light. And since infrared light passes through cosmic dust, the James Webb Telescope can see into regions of space that would be otherwise hidden, revealing newborn stars, distant galaxies, all hidden in the infrared. The James Webb Telescope was launched in 2021, and only time will tell what fascinating sights it will deliver us. Simple lenses in the 17th century used to view the moon to Earth spanning network of infrared telescopes. The telescope has done more than help us see. It has changed what we see, and more importantly, how we see ourselves in the universe. Anyways, that was all I wrote. This was AD from Silverlight Studio. Thanks for watching, and I hope you liked the video or maybe learned at least something from this video or at least found the video interesting. And if you did, don't forget to like, comment, and subscribe. Catch you later, Stargazer.